Welcome to Chemistry with Caroline. In this video, we're going to look at how to draw resonance structures for radical intermediates. So I have drawn below here a benzylic radical, so a structure that has an unpaired electron adjacent to the benzene ring. And we're going to show how that radical intermediate, how that radical character can get cycled around that ring because of its adjacent position to the pi bonds. And so I'm going to draw the arrows. What's going to happen first is we're going to form a new double bond coming out of the ring. So the radical electron is going to pair up with one of the electrons in the adjacent pi bond next door to make a new pi bond. And then the remaining electron in that pi bond is going to go out as a radical onto that carbon that's sort of farthest away. So I have this meet in the middle thing written up there, right? So when arrows meet in the middle, that indicates the formation of a new bond. So these top two arrows here are indicating that a new pi bond is going to be formed then. So let's look at what my next resonance contributor would look like. So right there is the new bond that I formed from those what I would call meet in the middle type arrows. And then I have one unpaired electron that is left after this, after these electrons have moved. And so if I start with a radical, I should have a radical in all of my remaining resonance structures. Now that I'm in the ring, this radical is adjacent to a new double bond. So this radical can come here, and then one of these electrons from the pi bond can come there to make a new pi bond, and the remaining electron comes out as a radical on the carbon over there. And that will give me this structure. And so now my radical is across from where my substituent is. Again, we get these meet in the middle type arrows. Whenever I'm pushing an electron and I've got a pi bond next door, I'm always going to have three arrows. So 3 electrons will move the radical and then both of the electrons in the pi bond. When I'm only moving one electron at a time, I'm using single-headed arrows. So you can see all the arrows that I've drawn here, they only have a head on one side, okay? And that indicates that only one electron is moving with that arrow that I'm showing. So now, after I've done this latest one, I would have this. And in the case of a benzene ring, you can go all the way around the ring. And so I would end up with my radical back on the outside and all of my pi bonds shifted over one. And that is how I'd know I was done. I've gone around the entire ring. All my pi bonds have shifted, but my radical is back outside where it started. So this has been a look at how to draw resonance structures when you have a radical intermediate. We use single-headed arrows to show the movement of electrons, and radicals that are adjacent to pi bonds are able to be delocalized throughout a pi system, just like a carbocation or a carbanion intermediate would be able to do that. If you found this video helpful, please like, subscribe, and share with your friends. Thanks.